Problem. A rock is thrown up from the cliff overlooking a pit. The rock first flies up, reaches its highest point, then falls down, passes the initial 0 point, and falls down further to the bottom of the pit. Given initial velocity of the rock, d is the depth of the pit. Question: find maximum altitude from the initial point. Find total distance. Find total time. Find and verify change in position, and find final velocity. First of all, we have to make sure that units of measure are consistent. Next, very important, we have to choose a coordinate line, and we choose y-axis directed up. So in this case, initial velocity is directed up, so it's positive. But acceleration due to gravity directed down to the center of the earth, so it's negative. And since our depth of the pit is below the 0 mark, it's negative as well. Question. So we went through questions, now let's do solution. First, let's find maximum altitude. We use the standard formula: square of final velocity minus square of initial velocity equals 2 times acceleration times distance. Since our final velocity is, let's say in here, we consider only this piece. Final velocity at point A is 0 because the rock stops at point A. So no final velocity minus square of initial velocity equals 2 times g times delta S1, that's first distance. Plug in numbers, we get the maximum altitude, 11.25 meters. And even if this formula in letters looks a little odd, we have negative sign in front, but it's okay because we remember that our acceleration is negative, so negative by negative will be positive. Next, let's find the total distance. Total distance is actually consists of 3 components: distance from B to A up, from A to B down, and from B to C down. Delta S1 is the same as maximum altitude from initial point. Delta S2 is the same as delta S1. And delta S3 is actually the absolute value of our depth of the pit. 42.5 meters is total distance. Next, let's find the total time. And let's use the standard formula where we have quadratic function that involves time, acceleration, initial velocity, and change in position. Plug in numbers, we get quadratic equation. Solve quadratic equation, we get 2 roots. Time cannot be negative, so it's a redundant root. So our total time is 4 seconds. Number 4. Let's find delta T1. Time from start to point A. We use the standard formula. Final velocity at point A only for this piece is 0. So 0 equals V0 plus acceleration times multiplied by delta T1. Plug in numbers, we get delta T1 equals 1.5 seconds. This formula, again, it looks a little odd because we have a minus in front. But we remember that minus and acceleration is negative, so final answer will be positive. Delta T3 is time from B to C, and actually it's total time minus twice time up from B to A, and time from A to B. It's the same time because of symmetry. So delta T3 equals 1 second. Now in here, in number 5, we verify, we already know that change in position is just depth of the pit, but we can verify this by plugging in the time that we found into this formula, and we'll get negative 20 meters. Again, this is negative sign, and this is important. Number 6, let's talk about velocities. So velocity at point A is 0 because the object, the rock, stops at that point. Velocity at point B is by absolute value equals to initial velocity, but it's opposite. Initial velocity up direction, when a rock falls down, direction of velocity is down. So it's negative 15 meters per second. Initial was positive. And the velocity at point C, which is final velocity, we can stick into a standard formula. Initial velocity, acceleration, total time, we have negative 25 meters per second.